Have you ever wondered why Australian kangaroos don't hop around in Asia, or why Asian tigers don't prowl in Australia? The answer lies in an invisible boundary known as the Wallace Line. This invisible boundary, cutting through the heart of Southeast Asia, has puzzled scientists and nature enthusiasts alike for centuries. It's a line that, seemingly arbitrarily, separates two very distinct sets of wildlife. On one side of the line, we find species that are typically associated with Asia: elephants, tigers, and monkeys. Cross over to the other side, and suddenly, the wildlife changes dramatically. Here we encounter species more commonly associated with Australia: kangaroos, koalas, and emus. The question then arises, why? Why do these species stay so strictly on their respective sides of the line? Why don't we see a blend of Asian and Australian species across the region? So what is this Wallace Line and why does it exist? Stay tuned to find out. The Wallace Line is named after Alfred Russel Wallace, a British naturalist who stumbled upon this peculiar pattern in the 19th century. Wallace was not just an explorer, he was a man with an insatiable curiosity about the natural world, and his travels to the Malay archipelago in Southeast Asia would forever change our understanding of it. Wallace embarked on this journey in the mid-1800s, seeking answers to the mysteries of nature. He was particularly intrigued by the distribution of animal species across the region, which was unlike anything he'd seen before. As he voyaged from island to island, he began to notice a pattern. On the western islands, the animals were similar to those found in Asia: elephants, tigers, rhinoceroses, species that were distinctly Asian in origin. But as he moved eastward, there was a sudden shift. The animals on these islands were more akin to those found in Australia. Kangaroos, wombats, and birds of paradise were suddenly the norm. This observation was puzzling. Why was there such a stark difference in animal life across a relatively short geographical distance? Wallace pondered this question, and after years of meticulous study and observation, he came to a conclusion. There had to be an invisible boundary separating these two distinct regions of animal life. Wallace proposed the existence of this boundary, a line cutting through the archipelago. On one side were the Asian species, on the other, the Australian. He called this boundary the Wallace Line, a testament to his discovery. But Wallace's discovery was more than just a line on a map. It was a testament to the power of observation and the quest for knowledge. It was a testament to the fact that the world is full of wonders, waiting to be discovered by those who dare to look. Wallace's discovery was a breakthrough in the field of biogeography, but what exactly does the Wallace Line signify? Stay tuned as we delve deeper into the significance of this fascinating demarcation in the next scene. The Wallace Line represents a deep geographical trench that separates the ecozones of Asia and Australia. This invisible boundary, drawn by British naturalist Alfred Russel Wallace in the 19th century, is much more than a mere line on a map. It is a testament to the fascinating diversity of life on our planet. The Wallace Line is a divider between two distinct ecozones: the Indo-Malayan region on the west and the Australasian region on the east. These regions, despite being geographically close, are as different as night and day in terms of their flora and fauna. The reason for this stark contrast lies in the deep-sea trenches along the Wallace Line, which during the Ice Ages remained as formidable barriers preventing the exchange of land-based flora and fauna. On the western side of the Wallace Line, we find animals and plants typical of Asia: elephants, tigers, and oak trees. Cross over to the eastern side, and it's a whole different world. Here, we encounter marsupials like kangaroos and wombats, and trees like eucalyptus that are quintessentially Australian. This division is so pronounced that even when humans first migrated to Australia around 60,000 years ago, they could not bring any Asian species with them due to the impassable natural barriers. This has resulted in a unique and separate evolutionary history for the creatures on either side of the line, contributing to the incredible biodiversity we see today. The Wallace Line is not just about the separation of species, it's about understanding the intricate dance of evolution and how geographical barriers can shape the course of life itself. It's a vital tool for biogeographers, conservationists, and nature enthusiasts alike to study and protect the unique species that inhabit our world. Now that we understand what the Wallace Line is and why it's significant, let's look at some interesting examples that highlight this. The difference in wildlife on either side of the Wallace Line is stark. For instance, consider the orangutans of Borneo and the kangaroos of Australia. Now let's delve a bit deeper. On the western side of the Wallace Line, the islands are home to a myriad of species that originated from the Asian mainland. The orangutans of Borneo are a prime example. These fascinating creatures are among the most intelligent primates, with their distinct behaviors and adaptations that suit the dense tropical rainforests they inhabit. They have long, strong arms perfect for swinging through the trees, and their diet consists mainly of fruit, particularly durians and figs, showcasing their adaptation to their lush environment. In contrast, the eastern side of the Wallace Line, including Australia and New Guinea, hosts a different set of creatures. Here, marsupials such as kangaroos rule the roost. Unlike the fruit-loving orangutans, kangaroos are grazers. Their long hind legs and muscular tail are adaptations that allow them to move quickly across vast, open landscapes, quite different from the dense rainforests of Borneo. But it's not just the fauna that's distinct. The flora on either side of the Wallace Line is equally diverse. The Asian side of the line, for instance, is characterized by dipterocarp trees, which are known for their two-winged fruits that spin like helicopter blades when they fall. These trees dominate the forests of Borneo, providing food and shelter for a multitude of species, including our friend, the orangutan. However, across the Wallace Line in Australia, a different type of vegetation prevails. The dominant trees here are eucalyptus, adapted to survive in an environment that is often hot and dry. These trees have hard, leathery leaves to reduce water loss, and their seeds are protected inside capsules that only open to release their seeds after a fire, a remarkable adaptation to the frequent bushfires in Australia. The Wallace Line also shapes the marine life. The Coral Triangle, to the east of the Wallace Line, is the global center of marine biodiversity. It houses more than 3,000 species of fish and hundreds of species of coral. On the other hand, the marine life on the western side of the line, while still rich, is significantly less diverse. These are just a few examples that illustrate the dramatic shift in biodiversity on either side of the Wallace Line. Each species, with its unique set of adaptations, is a testament to the power of geographical barriers in shaping the course of evolution. From the fruit-loving orangutans of Borneo to the fire-resistant eucalyptus of Australia, from the two-winged dipterocarp trees to the diverse marine life in the Coral Triangle, each paints a part of the grand tapestry of life on Earth. These examples showcase the profound influence the Wallace Line has on the distribution of life on Earth. The Wallace Line, an invisible boundary drawn by nature, plays a pivotal role in shaping the biodiversity we see today. We've traversed a riveting journey, exploring the mystery and intrigue of the Wallace Line and its compelling influence on Earth's biodiversity. It's time now to distill the essence of our exploration. We ventured back to the 19th century, to the moment when Alfred Russel Wallace, a British naturalist, stumbled upon this invisible line during his travels in the Malay archipelago. His observation of stark differences in species on either side of this unseen boundary led him to propose the existence of the Wallace Line, a concept that intrigued the scientific community and still holds its ground today. The Wallace Line is more than just an imaginary boundary. It represents a significant biogeographical divide, a separation between the distinct flora and fauna of Asia and Australasia. This line, though invisible, has played an essential role in shaping the biodiversity we see today. We delved into the significance and impact of the Wallace Line, understanding how it impacts not just the distribution of species, but also their evolution. The line acts as a natural barrier, restricting the intermingling of Asian and Australasian species, thereby influencing their evolutionary paths. Through various case studies, we saw the Wallace Line in action. The stark contrast between the species found on the islands of Bali and Lombok, despite their close proximity, is a testament to the power of this invisible line. In essence, the Wallace Line is a tangible reminder of the intricate and complex design of nature. It's a symbol of how geographical boundaries can shape the course of evolution leading to the diverse array of life forms we see today. So, the next time you wonder why certain animals or plants are found in specific regions only, remember the invisible line drawn by Alfred Russel Wallace. The Wallace Line, a testament to nature's fascinating and complex design.